sorry. Had to move my car. Bottom line is, there really is, you don't have to guess where these intersection points are, because the place that two graphs intersect happen to be where they're equal to each other. So x squared plus 2x plus 1 must equal that 2x plus 5. Subtract, you get x squared gone minus 5 minus 4 equals 0. They're going to, at x plus 2, x minus 2 factor, so they are going to intersect. Yes, they intersected there where x equals negative 2, right? But also where x equals positive 2. 1, 2, so whatever that point is up there, right there. Okay? So even though my graph didn't look perfect, we definitely see the two places they intersect. Negative 2, the y value will be 1, and positive 2, the y value will be 4 plus 5, 9. Alright, so to find that area between the curves, again, just do your little representative rectangle over here. Now, through the years, kids have been all up in arms about, that rectangle. And I will say, what's the height of that rectangle? And they'll go, oh, well, it looks to be like, 2 minus a half. 1.5. I'm sorry, 3 minus a half. 2.5. That's what they'll say. The height is 2.5. Well, this is just a representative rectangle, and the height is actually the top y value, 2x plus 5, minus the bottom y value, which is the x squared plus 2x plus 1. That is the height of that one. It is a dx or delta x, right? So dx right there, and because it's a dx, the x values go from negative 2 to positive 2. Now, obviously, in order to solve this thing by hand, we would definitely want to distribute the negative sign, and we'd have a negative x squared, 2 x's would be gone, plus 4 dx. So finish it. Antiderivative of negative x squared, negative x cubed over 3 plus 4x. Always plug in the top first. 2 cubed is 8, negative 8 thirds. 4 times 2 is 8, minus negative 2 cubed is a negative, times a negative would be positive 8 thirds, and then minus 8. Distribute that negative sign. Let's see, 16 minus 16 thirds. 3 times 16 is 48 thirds. Minus 16 thirds would be 32 thirds. 32 thirds. Let's check it out on the calculator. Math 9, negative 2 to 2. If we want to start from the 2x plus 5 minus the x squared plus 2x plus 1 dx, 10.66, I have a feeling, 32 thirds. So, easy peasy lemon squeezy if it's just one little problem like that. Let's go ahead and extend it to example 1, example 2. Let's extend it to two little intersections. x minus 1 cubed, and g of x equals x minus 1. I hope you can graph x minus 1 quantity cubed. You know what the cubic looks like. Minus 1 would move it to the right 1. Oh my goodness. Minus 1 would move it to the right 1. And left 1 down 1, if you remember. Right. And then y equals x minus 1 is just that straight line. Whereas oh my goodness. Alright. Let's take this and let's skip this. Let's make this 1, 2, negative 1, negative 1, 1. So x minus 1 would start here, rise 1, run 1, straight line there. X minus 1 quantity cubed is going to move it to the right 1, and right 1 up 1, curve up, left 1 down 1, curve down. So at least we can see a little bit more of this area we're dealing with, right? We got two little areas in there. If we're sure of symmetry, we can probably take 1 and double it. If we're not completely sure of the symmetry, let's just take two little separate ones. And they're vertical again. And so it's a dx, this first one. The x values clearly go from 0 to 1. And the top value is the cubic minus bottom value. Where people make the most mistakes here is they don't use parentheses here. They're not careful about which one is on top. But obviously, if you end up getting a negative number, go back and you'll see, oh, I put the wrong one on top. The top one for this right intersection is going to be the line minus the curve. Now, x minus 1 quantity cubed. If you're a Pascal's triangle person, 1, 3, 3, 1, that is going to be x cubed, minus 3x squared plus 3x minus 1 minus x plus 1. We'll end up canceling those, and will give us x cubed minus 3x squared plus 2x, it looks like. And then that will give us x to the 4th over 4. Oh, looky there, just x cubed and x squared. Plug in your 1, 1 plus 1, plug in your 0. That's just 1/4, which makes sense. It's a teeny tiny area. So that area is just a 1/4. Plus, here we have the x minus 1 minus all that stuff we just did, x cubed minus 3x squared plus 3x minus 1. Change all the signs would give us negative, positive, negative x cubed plus 3x squared minus 2x, and the 1's are gone again. So if we plug in the 2 first, negative, I almost forgot to take the antiderivative. Negative x to the 4th over 4 plus x cubed minus x squared. Now, plug in the top first, would give us negative, right? 2 times 2 would cancel out that one, so there's a negative 4 plus 8. 2 squared is 4 minus negative 1/4 plus 1 minus 1. 8 minus 4 minus 4 goes to 0. Change both of the, or all those signs, they're gone. Another 1/4. 1/4 plus 1/4 is 1/2. So there was symmetry. We felt pretty confident about the symmetry, and turns out we could have just taken one of them and doubled it. And that does show up occasionally. Now, there's only one wrinkle in the problem, and that's if it gives you something, let's say x equals 4 minus y, and x equals y squared plus 2. I hope this works. I reserve the right to call it minus 2. So we can find where these intersect. This is why I'm jumping, because y squared plus 2 equals 4 minus y. Subtract, oh, I think this is going to work. Y squared, if I add the y and subtract the 4, I get minus 2 equals 0. Factors plus 2 minus 1. Okay, so we do have two easy y's. Y equals negative 2 and y equals 1. We have places where they intersect. Now the issue that we have is we haven't done a whole lot of graphing with these. I tried a little teeny bit last year in pre-calc to look at the side-to-side things. If I just took off that plus 2 and I had x equals y squared, that is kind of like y equals x squared, but it's turned side to side, and this is like the parent graph, right? But a plus 2 with the y is going to be like a minus 2 with the x. So this is moving to the right too, I believe. If I plugged in a 0 for the y, the x value would be 2, correct? So, and again, it's going to be the same, the coefficient is just 1, so it's just going to be that beautiful little look right there. Now, x equals 4 minus y. Guys, if I'm trying to graph this, I solve for y, and it would be negative x plus 4. So, plus 4, 1, 2, 3, 4, down 1 over 1, down 1 over 1. So we can kind of see that these do intersect when y equals 1. That is the point 1, 2, 3, 1, in fact. And y equals negative 2, right here. This is the point 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Negative 2. So, this is our area that we're looking at, right? I pull in. Now, I can try to draw that vertical representative rectangle, and it looks fine here. Oh, but what happens if I get over into this general area? I'm connecting two parts from the same curve, and that's a problem. So I cannot draw vertical representative rectangles for this one. I'm going to have to draw horizontal ones, because all the way from the top to the bottom, that, you know, we connect just the line with the curve. And if I'm looking at that one representative one, it's a delta y or a dy for our width of that one rectangle. See the difference? If it was a vertical one, it's a change in x value, right? The little width of that one rectangle. but the width of this one is a dy, which helps because so far we have x in terms of y, right? And so if I think about it, just like I always did top minus bottom, if we have a side-to-side graph, I'm going to say right minus left. And so the right x value is going to come from the line, 4 minus y. The left comes from the curve. These are x values, the x value here minus the x value there. And the width of that, of each of those, is a delta y or a dy. And the y values go from -2 up to 1. Biggest mistakes people make here, they try to use x values when they need to use y's. But now if I were plugging and chugging in a calculator, I would absolutely just call that y an x, that one an x, and that an x, and it would get me the correct answer. 4 minus y distribute would give me 2 minus y squared, right? Again, that was a rewrite. Take the antiderivative, y cubed over 3. Always plug the top one in first. 2 minus 1/2 minus 1/3 minus -4. Positive 4 over 2 is 2 minus negative would be positive 8/3. You could free response, but there are many of these you will have to find by hand. So 4, 6, 8 minus 9/3 would be minus 3, right? Minus 1/2. 5 minus 1/2, 4 1/2, 9/2. Done. Does that 4 1/2 make sense if I count my squares? 1, 2, 3. Yeah, 1, 2, 2, 3 full ones. I think 4 1/2 makes every bit of sense, even with my kind of sloppy graph. I mean, that's the bottom line, how to do it. If the function is listed as a function of y, chances are high you're going to do horizontal dy's. If it's a function of x, you're going to probably do vertical ones. See if I can just do, this is problem number 30 on page 454. Just looking at how difficult they go here. F of x equals the cubed root of x minus 1. G of x is x minus 1. And the directions say sketch the region bounded by the graphs and find the area of the region bounded by those graphs. So, the cubed root, I think I'm going to make my units big again. 1, 2, 1, 2. X minus 1 is just y-intercept -1, rise 1, run 1. The cubed root of x is this curve this way and this way, right? Minus 1 is going to move it to the right one. So it's going to go this way. This, I would bet you money, is going to be the exact same area as that one we did as an example. Let's understand some symmetry. If I'm going to just do this one and say that's got to be symmetric, right? So I'm going to say 2 times the integral from the x value goes from 0 to 1 here. The top is the line minus the bottom is the cubed root, which is really the 1/3 power. Don't go brain dead with our antiderivatives, because antiderivative of x squared over 2 minus plain x. This is a blob to a power, but the derivative of that blob is a nice easy 1. No manufacturing needed. Keep the negative out in front. Don't touch the blob. Add 1 to the power. 3/3 plus 1/3 would be 4/3. Divide by 4/3. Multiply by 3/4. Plug and chug. 1/2 minus 1. 1 minus 1 is 0. 0 minus 0. This one will be negative 3/4. Negative 1 to the 4/3. Cubed root of negative 1 is negative 1 to the 4th would be positive 1. Minus a negative would be plus 3/4. So I think that's half minus 1 is negative a half. Plus 3/4 would be 1/4. Times 2 would be 1/2, which it turned out to be exactly the same. It almost looked like the same. It was just curved differently, wasn't it? But the figure looked the same. Very interesting. Again, looks like the majority of the ones that you'll have to do are just quadratic. And remember to take your derivative, set it equal to 0. Find that max or minimum point there. So let's get your assignment here. Pages 454 to 455. Before I do that, let's do one more all on the calculator. Let's look at number 42. 42 says f of x equals x to the 4th minus 4x squared. G of x equals x cubed minus 4x. Now, finding those intersection points might not be easy if it was not a calculator problem, but if it is, it's a matter of using our calculator and all its capabilities, right? X to the 4th minus 4x squared, x cubed, arrow right, minus 4x. Let's see what Zoom Standard does to it. Oh, pretty nice. Really nice. I'm having a little issues with right there, so let's just go like -6 to 5. See if that shows us a little better. I'm seeing like 3 little sections showing up. As long as they don't intersect again up there, which I'm pretty sure they don't. Let's show a little bit more just to make sure. This one crosses. Yeah, they kind of, the 4th one grows really fast. It will never cross again. But I'm clearly seeing those 3 intersection parts. However, I told you in the instructions, if it's a calculator problem, we really just need to find the outermost intersection points. And so, second trace intersect, number 5. Just arrow over and get it near that intersection. Enter, enter, enter. x equals a -2. Second trace intersect. The outermost intersection point is +2. Now, I'm guessing it intersects again in there. Pretty sure. At 1, looks like it might intersect at 0. Oops, second trace intersect. Probably intersects at 0 also. Oh yeah, no doubt it intersects at 0. But we know those outermost intersection points, right? So this top one was my y1, right? Bottom one was y2. So let's look. The integral from the leftmost intersection to the right, and put y1, or if you're writing this as, and this is how they're defined on your graph, just put f of x, absolute value, f of x minus g of x dx, and then it would be approximately equal to math 9 -2 to +2, I'm sorry, of y1 minus y2. Oops, I forgot the absolute value. Daggone it. Sorry, there was an interruption. Math num. And let's just go y1 minus y2. Delete, delete. There we go. And it's not just going to be the opposite of that, because we have multiple areas between there. 9.767. Now, we probably could have done that by hand, especially since they were nice little easy intersection points, but we would have had to have done, you know, for this first one, integral from -2 to 0. The top one was the g of x, right? Minus f of x dx. Then plus 0 to 1, and the top would have been f of x minus g of x, right? Then we would have had 1 to 2 of g of x again minus f of x dx. So again, much easier on the calculator. Find those intersection points, second trace intersect. By the way, if the intersection points,
Pay attention, please. There's a gray van in the back of the school up near the curb.
if the intersection points are not beautiful, easy numbers, use storage feature, right? Store it in for, you know, alpha A, and then use the whole value. Don't just round those numbers to 3 decimals, because your final answer will not be correct. So, hope that gets us going enough. Let's go 1 to 5 odd, 17 to 33 odd, and then 37 to 43 odd. Good luck. Hope it goes smoothly. And we're on our way to the last of calculus. Have a good